Hi, my name is Semjon and I want to show you how you can create your own fake rain surface shader with Unity. The download link to the shader, the timeline and also the credits you can find in the description below. I split this tutorial and the shader in 3 big parts and many subtopics, so you can follow me step by step through this video. In the first part I explain some basics about the Unity surface shader, how you can apply diffuse, normal, specular and custom textures, and also how you can write your own lightning function. As an example I show you the half lambert lightning function. If you don't need this, you can also, needless to say, just skip to the next part. In the next part I show you the actually fake rain shader, where I'm using a layer mask which I'm applying on the UV coordinates to manipulate the texture information and create a fake distortion. As well, I add a cube map reflection and a rim light to create more glossiness and a wet surface. In the last part I show you some features for your scene to create a rainy mood, like a particle system, a looping sound, the skybox and the fog. It would be good if you have already some basic knowledge about the Unity editor and programming. For this tutorial I set up a new project on File, New Project and call it Fake Rain Tutorial in the project location and click Create. Select a folder from the directory if the folder didn't already exist. After the new project is loaded, first of all we import the textures which we want to apply on the surface, respectively on the object. Therefore we can right click in the project field and import a custom package like the package from the download link, or just drag and drop your own textures in the same area. Afterwards we save the current scene with the shortcut Ctrl+C, or create a new scene under File, New Scene and name it Fake Rain Shader Tutorial. With right click, create shader in the project field, we just create a new shader file. Use the key function F2 to rename the file into FakeRain_shader. With right click on the new shader file on Create Material, we create a new material which already has applied our shader. In the material inspector you can see already the impact of our default shader, where we also make later bring in the input. Again, you can rename the material with the key F2 and call it FakeRain_material. To demonstrate the shader we can create some objects where we can apply the material. Go to Game Object, Create Other and create the plane and the sphere. Now we can apply the diffuse texture from our package and drag and drop this to our material in the texture slot, or just left click select and select the texture. Don't forget to assign the material to the objects by drag and drop it direct in the scene or in the hierarchy. Also we need to create some light. Don't go again to Game Object, create another and create a directional light and a point light and place them in the scene. If you like, you can tweak some settings in the inspector. With double click on the shader we can now start to edit the file in mono development. This is mono development and our custom shader which Unity already prepared. I go through line by line and try to explain the meaning of the code. In the first row you can see where you can find the shader in the editor to assign it on the material. At the moment you will see you will find the default shader under custom FakeRain_shader. Let's change this to tutorial FakeRain_shader. The properties lines are the area where you can define public variables which can be changed by the editor user to influence the shader calculation. As an example, we add a color. _color is a variable name. Every public variable must start with underscore. With this sign, the program recognizes that this variable is being using as a public editor value, and it takes this information into the calculations. quote marks, color, quote marks is the description in the editor, and color is the data type. 1111 is the default color value, vector with 4 number values. The first 3 are the RGB value, and the last is for the transparency, or just write down white if you want. The underscore main text is of course representing the main texture, which is the diffuse texture. Also here the first 3 channels are the pure unlit color informations, RGB. The fourth channel is the alpha channel and is the transparency. For this reason I renamed the description so the user knows the definition of the texture. The data type is 2D and the default input is also white. And the subshader is actually where the whole fun is to write down the shader. The literary fallback is the diffuse shader here. So in case of older hardware, the system falls back to the shader. The text can be used to define how they need to be rendering in the rendering engine, but we don't need to change this. LOD 200 is the level of detail and describes from which distance the shader gets reduced to save performance. Also we don't need we don't need to change this. The first line of CG program hash pragma surface surf lambert. This means we create a surface shader. There are also different shaders like a vertex or a fragment shader. We're using the function surf to calculate the surface output, and we're using the Lambert lightning model to calculate the light. I like to rename this, the function surf to the rain surface, so it's easier to read and understand for other people and myself. Here we come to the transformation from the public variables to the CG variables. Don't forget the naming conventions. Sampler 2D underscore main texture or underscore main text is a declaration of the underscore main text variable. Sampler 2D is here the data type. Underscore main text is of course the name. Don't forget the same for the color. We have half 4 as the data type with underscore color. 1/2 is the data type with the half range of a float, so we have here 4 half floats to define the underscore color. This in the struct field you can define values which you can just read out. It's a kind of a data transfer like a messenger. It's not to use to reference. The surface function themselves, now I named the rain surface, calculates the surface output. It does not return any values. With the dot behind the variable we can define the albedo output from the first 3 values of the diffuse value. The last value defines the alpha value. I like to rename D to diffuse value. Here we define the diffuse value is color information which we read from the texture underscore main text on the coordinates of UV underscore main text. Now we want also to multiply our custom color information underscore color with the diffuse value, so we can tweak around in the editor. In the editor you will find now the new variable color which you can now change on the fly. Now we want to apply a normal texture to the surface with the aim to fake depth and height of the surface without manipulating the actual geometry of the object. A normal map contains also color information. Those can be read out and transformed into different normal vectors, as the name implies, to simulate a bumpy surface. Like the main texture, we define the properties and describes the texture. The fourth channel here is a specular texture which we need later. Also don't forget to declare the underscore normal text like the underscore main text. For the normal texture we use the same UV coordinates like the underscore main text, therefore we don't need to extend the input struct. In the surface function we want to output the modified normal vector through the normal map. The normal vector value has 3 values, x, y and z, and needs so a half-3 data type. As with the diffuse texture, we read out the color information with the function text2d from the underscore normal texture on the UV and on the UV coordinates UV underscore main text. Additionally, we need to transform this color information into a normal texture with the function unpackNormal. Now we want to find the normal output by o.normal equals normal value .rgb. .rgb means we just pass the first 3 information channel of this vector. After this code line we can now apply our normal texture into the second texture slot. Don't forget to change the texture type of the normal texture in the inspector of the normal map. If you just have a grayscale texture, click the checker box so Unity transforms this texture into a real normal map. Otherwise, don't click this texture box because it forces errors in your texture. Now we can see the normal texture gives the surface much more details and interacts to lights. In this step we want to create our own lightning function. We need a new function which returns a half-4 vector and needs the prefix lightning in the name. I call it lightning half lambert and replace this function name in the pragma line lambert to half lambert. Here we need different input parameters for this function. The first parameter is the surface output O. This value comes from the rain phase function. After we need half-3 light year, which is a vector where the light comes from. Keep in mind that every nearby light get calculated through this function. The next parameter is half-3 view year. This is a view direction vector of the player camera. In the end we need to have atten, which means attenuation. This is kind of a value that describes the distance and the intensity of a nearby light. The first thing we need to find out is the shading value of the light. In other words, how strong gets the light reflected on the surface. For this we need a helper function with the name half-dot. This function returns this shading value and we need this function later often. This function takes 2 half-3 vectors, and the first is the surface normal and the second is the light year. It's important that this helper function stands above the actually lightning function. Like I said, it returns a half and takes 2 half-3 parameters. We use the function dot, which is the mathematical method to calculate one value. If the vectors have a length or attitude of 1, which can be done with a normalized function, this method calculates a value from -1 and 1, and we can use this to compare the two vectors, how similar are they to each other. If we now multiply this value with a half and we have a range between -0.5 and +0.5. If we now additionally add 0.5 to the value, we have a returning value from 0 to 1. This means we have now much smoother shading as the regular lambert function, and it prevents the rear of the object is losing its shape or it's looking too flat. At the actual lightning function, here we calculate the lightning and diffuse lightning, so we need now to multiply the shading value with the received surface output of the albedo color and the light color. In the end, we need to calculate the return color, which is the product of our calculated diffused lightning, the attenuation, and the light power. The light power is another value for the editor to use to tweak around the shader, so he has more freedom. Don't forget the property definition and the declaration. Now, finally we return the vector, which need to be a half-4, so we use the function half-4 to add the original alpha value to the returning color vector. The alpha value we get from the raining surface. Now we can see we have a much smoother shadow. Now we extend our shader with a colored specular texture, which means that the surface reflects the light different depends on the specular texture and the camera position. This additional light reflection and the normal texture can define various materials and states of a surface like metal, plastic, liquids or organic stuff, and much more. Sometimes, but you will also find the name glossy texture instead of specular texture. But let's go. Like I said, the previous part we refer our specular texture from the fourth channel of the underscore normal text. Also, we need to extend the properties with two variables more, the underscore specular power and the underscore specular color. So the editor user has again the freedom to adjust the shader. And don't forget, after the definition, the declaration, because the default surface output struct don't support a color for the specular. We need to extend this struct by writing our own struct. We create a new struct with the name new surface output, and first we define all default values like the half-3 albedo, half-3 normal, half-3 emission, half specular, half alpha, and finally we extend this struct with the half-3 specular color. Don't forget to replace the old surface as output struct with the new surface output in the lightning half lambert function and the rain surface function. Next we extend the lightning function. First we calculate the specular value, where we use again the helper function half dot with the surface normal vector and the vector sum of the light direction and the view direction. So this means only if we look exactly in the opposite direction on the reflected ray on the surface, this point is the most highlighted point on the surface and we have a perfect reflection on the specular. This perfect reflection is dependent on the variance of the view directions angle and the specular texture. That gives us a smooth specular dependent reflection. Would we use just the view direction instead, the light reflect would be too bright. If we use the light direction, we would only just copy the shading value. With POW function, what actually is the exponentiation in the mathematics, the returned half dot value, which is the base, and the underscore specular power is the exponent, we get more control over the specular value. After that we calculate the specular lightning by multiplying the specular value with the surface output of the specular color. Because we don't get any information from the specular color, we need to create the output value in this rain surface function. So we define the specular value there there through reading the color informations from the fourth channel of the underscore normal text on the same UV coordinates. Here we define the specular color from the struct by multiplying specular value of the texture with the color of the editor, which we need for the lightning function. Don't mistake the specular value with the specular value of the lightning function. Back to the lightning function, don't forget to multiply also the light color 0. I made a little mistake in the last part. I named the diffuse lightning diffuse value and I changed it at this point. Finally, we add the specular lightning to the diffuse lightning by using round brackets. If you want to apply your own colored specular texture, you need to create a separate half-3 variable and output all 3 channels. Then, here I forgot a semicolon after the alpha variable. Now we can play around with the specular.